Hello everyone. Good to know. Welcome to the OpenStack LA meetup. I'm Mike Perez, and this is Matt Walker. And so today we are celebrating the birthday for OpenStack. It's the third birthday since its inception up in OSCON. So, yay. So I wanted to thank the foundation for basically sponsoring this entire meetup for today. And we have food thanks to them. We have delicious birthday cake from them. We have beer and soda and water. And let's see, what else have we got? T-shirts. Oh yeah, we have shirts. They gave us this print design. Yeah, they gave us a print design, and so luckily our marketing team was able to do that last minute for us. So thanks. So we're going to hear about O today, which is pretty awesome. I'm excited to learn more about it myself. Learned a lot at the summit, but kind of fill in some of the gaps. Probably hit up Clint for some more information on that. And of course, Clint Byrum is presenting for us today. So thank you. And so after this, we have a message from the foundation that I wanted to play afterwards. And after the presentation, we'll also just be mingling. There's also a camera set up in the lunch area right there, or dinner now. And basically, the foundation would really love it if anybody wants to, in their native language, to go ahead and say, "Happy birthday, OpenStack." So that would be really cool, and I'll be passing on all video and pictures that I take tonight to the foundation, and they'll be sharing them up at their party in Portland at the OSCON party on the 24th. So all media will be shared just on their little slideshow thing. So cool. I think that's pretty much it, all I want to talk about. Oh yeah, hashtag OpenStack 3BD day. So if you want to live tweet or anything, you're into that. So cool.
What's that hashtag again?
It's OpenStack 3B day. So cool. And also I started up the Twitter account for OpenStack LA, so you can follow us and get updates. And I mean, you already get the updates to the meetup anyway. So, but yeah, if you want to enter that. Cool. So Clint.
Today I'm going to talk about O, which actually I'm pretty excited about this. If you haven't heard, in the recent Foundation Board or Tech Council meeting, Tech Board meeting, I can't remember the exact name of the body who did this, but they have blessed O. They have blessed it as OpenStack deployment. So this is now the official way to collaborate on how to deploy OpenStack. And specifically, it has a mission statement, which is to deploy OpenStack using OpenStack itself wherever possible, which is where the name O comes from. I'll say that most of these slides, maybe all of them, are courtesy of Robert Collins, also known as Lifeless. So we should also thank him for making my presentation better. So I want to pull everybody first and ask who has deployed OpenStack, and for what thing did you deploy OpenStack? Noting that most of it might be covered on this board. Compute, right? You needed to be able to divide up your compute resources. You need to maybe have software-defined networking. Anybody dabbling in that? You need to be able to have object storage and scales and volume storage and scales, right? These are pretty fundamental IT problems. That's really what OpenStack is giving people a way to sort of put an accounting layer and an authentication layer and an API in front of those things, so that there's no longer this call the IT guys and wait, right? That's what the cloud has done for people. Is now there's not just self-service, but there's high service, meaning a high level of service for all components of IT. And there's another thing that enables. Once we have the API, right, we have velocity. So applications can now be developed faster. There's no more, let's try it on the hardware, and then we'll rejigger, and oh, we're stuck with the hardware we've got, right? You can reconfigure that Neutron networking. You can get bigger compute instances. You can play around with volume stores. You can start to put things in object storage. You have velocity. You have an API to do it. We've enabled your developers, and that gives you agility in your organization. That's what a cloud is supposed to be. There's all these things about utility computing, and I kind of disagree with the model of utility. I think it's not a good analogy, because whenever you're using a utility, you're consuming something, right? But actually, I think it's more like transportation, because transportation takes your goods from one place to another. It is somewhat of a commodity service, but it's definitely not consuming your goods. Just like when you're using OpenStack, you're actually putting your data into the compute node, right? You're taking the results out, so your data is your goods, and it's more like transportation. So one of the interesting things when you get to that is, so how do we deploy OpenStack? Right there. We're done. Right? Deployment is solved. It's a solved problem. Somebody figured it out. They were like Verizon and Swift and Glance and wow, and the Nova, look at just the Nova box. Right? Like, just deploy Nova tomorrow. Right? Just go open up the deployment guide. Oh, wait, there's one more. Open up the manuals on Nova and just get it deployed, and you're going to have a bunch of machines, and they're going to be interconnected in really complicated ways. What I see there, what we see there in the O project, is an extreme amount of complexity that can ultimately be broken up into a few different kinds of resources and how they interconnect and how the dependencies work. If you look there, really what you have are things that need compute, things that need storage, and things that need networking. Right? So if we want to deploy this efficiently and be agile as it grows and changes, right, we need a system that can give us automation on compute, networking, and storage. Right? So what do we have? We have OpenStack, right? Like, that's what we have OpenStack for. So the problem with all that complexity, though, is that it ends up giving us these things, right? We get bugs. With complexity comes problems. Duct tape and chewing gum stuffed in all the corners of OpenStack. We all know it. Some services more than others. There's another interesting thing that comes with that, which is entropy. And if you're at a level of like maybe 10 servers, you don't have a ton of entropy, right? Entropy would be just expected differentiation. But when you're getting up to 100 servers, 200 servers, 1,000 servers, entropy starts to get magnified. The impact of entropy overwhelms the benefits and ease of deployment. And that's one thing that we've seen is that the current deployment methods out there, of which there are many, right? I think you're using Chef, you're using Puppet, you can use Canonical's Juju solution with MAS, which I was involved with a lot. There's a bunch of ways to do this. What we find is that a lot of them are not doing enough to control entropy in systems. So you're installing packages, you're configuring things on live systems, and then users can come along and change things in an unexpected way. If your Puppet manifest, if your Chef cookbook doesn't have anything to do with that, then the entropy stays and it replicates and it causes problems. And there's also problems regarding hardware failure. So the idea with O, the idea with OpenStack and OpenStack is a large-scale deployment. I firmly believe that the small-scale deployment is a solvable problem without O, but OpenStack isn't really building a distributed system for small-scale deployments. We definitely want to make that easier, and we want you to start from a position where you can grow. So one goal of O is to be in the game. So everybody knows what the gate is. OpenStack development is built on the idea that no commit lands until it has gone through every test that we want it to. It has to pass every test. These are from as simple and annoying as formatting checks in the code, just so that we don't have to have like words about spaces and tabs, to the Tempest test suite is just like 700 different tests that run where you actually set up in a VM, you set up like a mini OpenStack and hit it and make sure that it actually still works, right? All that stuff has to pass every commit. Now, the infrastructure team, which my boss, Monty Taylor, also oversees their work at HP, and he's involved with that heavily. They've done an incredible job of making the gate as efficient as it can possibly be. There's 1,000 developers putting code into OpenStack. I think there's 600 active. There's been 1,000. There's just hundreds of commits per day. And if you, even if they have thousands of VMs, trying to get those all serialized into one commit and run 700 tests would not work. So there's actually a thing called Zool, which is really, really interesting. James Blair came up with it, and basically it groups the commits and tries to get them all to pass, and if they all pass, then they all commit once. And if they don't, then they all don't pass. And then he tries again to skip a bisect. But what that's done is that's kept OpenStack's velocity really, really high. So contribution flows into OpenStack. So we want to continue that with deployment. When you deploy OpenStack, right now the model is kind of like, well, I have Grizzly, right? It's the latest. But if you look at what's gone into Havana, there's a lot of really, really attractive features. And the public cloud vendors, my employer, HP Cloud Services being one of them, don't want to wait 6 months just to start testing and considering and rolling that out. Or even 3 months to get to, like right now we just released H2, Havana 2. But that's too long. That's too long when you're running a public service, especially when you have to respond to bugs today. So there's a continuous deployment model that has to be part of it. And OpenStack, on OpenStack, is focused on that. Now the releases will work because releases are actually a subset of continuous deployment. So if you think of continuous deployment as every commit potentially goes out live in your production deployment, well then releases are just only doing that every 6 months. So there's a greater potential for short-term damage when you have continuous deployment, right? You can deploy and fail. You need strategies to mitigate that. One strategy is just to spend 6 months testing and then hit the button every 6 months. If you're willing to wait, if you can wait, then that works. So another thing that we want to do with OpenStack is drive the cost of deploying and managing OpenStack down. And one way to do that is now you only run one system, right? So if you're learning OpenStack, you're learning how to deploy OpenStack. You're not also learning the other tools like Razor, like Crowbar, like Maz, things like that. So I kind of already covered some of this, but so the bugs that are inherent in a giant, complex distributed system, CI, continuous integration helps. CD helps too, and then you can fix a bug and have it roll out, get to your website. Right, so that's why we're doing that. The entropy problem is interesting, and it's probably the most controversial thing we're doing in Triplo, and it's also the one that we haven't finished yet, or one of the things we've never really finished at all, which is we don't really believe in packages. We're rolling unrolling images. So the idea is you build an image, you do all the complex work of building, installing, configuring in any way that's not machine specific beforehand. Save that in image, and then run it through your tests. And then if that image passed your tests, you deploy only that image. And you have root and read only. So you store your data on another volume. And root is read only. No one can touch it. There's no entropy in the software. So data becomes the only entropy. And then you have your configurations, and the configuration is actually potentially data. So configurations for the machines that are specific, those things can change. But the root file system that we can go in and edit Python files directly just to fix a problem. And then why does that box work and none of the other ones do? And then we also are focusing on chain. So this is the workflow of continuous deployment. Has anybody done continuous deployment for real? Excellent.
Yes.
Has anybody tried and failed? Like I kind of
I've done that too.
Yeah.
Continuous failure?
Continuous failure.
Continuous rollback?
You can call it continuous rollback. I like that. It's complicated, right? It's a well-known problem space. It actually goes back to manufacturing days, right? Like Toyota. does continuous deployment, where they, as the car comes off, like the engineers and the people who are actually holding parts on and testing things are actually feeding data back in and reporting bugs in that system. And the next car that comes through, they'll be like, oh, don't do the wheel this way, do it this way, or switch the order. Like that, they actually we're actually some of the pioneers in continuous deployment, and we're copying a lot of the methods. And one of those things is by marking points in a time where it's like the car is exactly, we know it's known state, that's the image deployed. So if we were doing a package-based deploy, like you think it might be the same as the last circuit, but it might not be. Whereas if you're doing an image one, it's bits, right? You just lidded the bits. Unless there was literally an unfound memory error during that transfer, like the bits on disk are the ones that were on disk. So in this process, we found that there are a ton of tools. And you'll see all the tools I've been mentioning up there. And we have this really strong desire to adhere to the Unix model, which is there's one tool and it does one job, right? Like sort, what does sort do? It sorts stuff, right? It doesn't also change data, that's set's job, right? It doesn't also do complicated field-based management, that's Ops' job. Like sort has one job. And what we found is that all the tools in this space have like 4 jobs. So these are some of the most important jobs. They're not all the jobs in deploying an OpenStack cluster. Provisioning hardware, delivering software, configuring a machine once it's booted, managing the state as the machine is going through its life cycle, and orchestrating multi-machine changes, right? And if you look through this, like Juju, which is the one I spent the most amount of time on before working on O, tries to do almost all of these, right? And what that's done is, like, Juju's really cool. I don't know, has anybody actually tried it? Like, it's really fast and easy. Like, if Juju already does what you need it to do, like holy cow, it's really good. The problem is that because it's playing across multiple spaces, when it doesn't do something in any of these spaces that you need it to do, you're now becoming a Juju expert. Juju's a big system. And oh, by the way, it's written in Go, and there's just, now you've added cost. Whereas the tools that we've written, like OS apply config might be up to 500 lines of Python. It's a really simple script, and it uses mustache templates, which if you've ever used mustache templates, they are logic free. The only thing they can do is display something rebellious. That's it. And the idea there is templating config files don't need case statements and while loops, right? We're not writing web pages. We're just trying to display like values that come in from another system. So that's a very simple thing. And every time we needed it to do something else, it's very easy to just extend that a little bit. And other people who come into the O project go, oh, I need to do this, and they can extend that. What's also good about that is if you don't like OS apply config, do Puppet. If you're used to it, Chef. It's got a templating language. They'll do that job. The problem that you see is that Puppet and Chef, right, they expand, they go into those other areas. So now you're going to start breaking these barriers between the jobs, right? Because once you pull in Chef under the system to do a templating job, it can also manage the state of your daemons, right? It's actually kind of cool the way it does it. But by crossing those bounds, now you're a chef. You're in chef land. And if chef doesn't do what you need it to do, you now become a chef expert. Now, being a chef expert is a good thing in today's economy. Right? Knowing chef is probably a valuable skill. But if you just had to learn OS apply config and use the stock components of all the other things, you would never have to learn anything else. So that's the idea, is that use one tool for each job. You might notice Nova in the provisioning. Is it everybody aware that Nova has a bare metal driver? So that's an important fact, and it was one of the first things that the O project did before I was even involved, was get that working. Now, since then, they've actually split a lot of it up, just like in OpenStack tradition. split a piece of Nova into another project. So that it's called Ironic, and which I think is ironic. And it's not only involved with doing bare metal compute, but also bare metal volumes. So your servers have disks in them, and Ironic will be able to identify those, and then you'll be able to do something interesting like define the disks in that server as volume X, and then you can redeploy to that volume. So you can like destroy the software part of it, but redeploy and get your data back. So the volume and the compute have a thing, which is really interesting. By the way, stop me. So these are the components. I just recently finished writing OS collect config, which is a replacement for some of the heat tools. If you were here last week or last month, you saw Adrian talk about heat, which is a cloud formation work-alike and more now. So OS collect config and all the other ones are kind of meant to replace the cloud formation tools, the work-alike tools that the heat project wrote. There's also disk image builder, which I find interesting and is totally useful without any of this stuff. Which basically it's meant to do extremely fast image customization. So what we do with it is we say, give me a VM that has Ubuntu and Nova Compute and these OS star config tools and a Nagios agent on it. And it goes and it just downloads just the vanilla Ubuntu image, mounts it in a true, installs the packages, and then saves that image for you. You do that too. That sounds simple, but it's a pretty complicated process. And the idea there is that we want to get that as fast as we can. So when you change your software, your images come out fast. So it's useful even if you don't use triple, just to make images. So Nova Compute, the bare metal driver, it just uses Pixie and IPMI. It actually also has a virtual power driver, so I actually use it on my laptop to deploy OpenStack. So if you've ever deployed DevStack, when you then do VMs, they're slow because they're nested. So if you use the bare metal driver, it actually boots a VM on your machine running native, so it's not slow.
What's the state of the bare metal driver in concert with Neutron, specifically provider network?
Perfectly.
The provider network aspect?
Yes, but VLAN. Really, you have to use VLANs. Because we don't have Open vSwitch, right? Like we need a VM for that. That's what Open vSwitch is. So you have to be using VLAN.
The reason I ask is last I heard I needed a kind of a separate Pixie DHCP environment to be able to bootstrap my new Nova Compute node.
It's a good idea because Pixie is inherently insecure and IPMI is pretty much insecure. So you want to have a provisioning network to do this. There's strategies. You can mess with port security and things like that on your switches, but for the most part, bare metal, you want to be booting and sending images out on one network and have tenant traffic and everything else.
So there's a concept of integration with the provider networks where I can image a Nova Compute node and have it attached to.
Yes, but if you know the limitations of VLAN networking, you're essentially you have to be able to define the VLANs out of your switches. There's a theory that you could use like the nicer products with it too, right? Because they actually do change things, but that's actually beyond my knowledge thing. But it's bare metal, right? So you have a lot less control over the network.
Right.
Like we can tell it to boot and use that VLAN, but it actually has a port on whatever network it's plugged into. It's not like Open vSwitch where I say just plug it in that bridge, right? It's like we've lost our switch man in the middle, and the way to do that, I think, is open flow switches eventually, and that is something we want to do.
Really, all I need to do is to Pixie boot it and then apply a network bonding config to the interfaces, and then insist on all the VLANs I need to, and it's good to go.
Yeah, and that's how we're doing things. Is just we have like a known set of VLANs that are plugged into known set of ports.
Okay.
The way we've written the heat templates and the OS apply configuration files and stuff, We just tell it, like, here's our known configuration for this particular network, and it attaches to the right physical networks.
So, did you make Grizzly, or do I need to go?
Grizzly's works with kind of a janky DHCP method.
Right, and that's the concern.
And
is
Havana
it's
uses actually Quantum's DHCP.
not- Okay, awesome.
So in Grizzly, the bare metal thing, just because Quantum didn't know anything about it, you just like don't run the DHCP agent. You run a DNS mask that's specially configured, and it works. Sort of through magic of knowing where /TFTP is and stuff.
Right.
But Havana's much more well integrated. I guess.
Sorry, I keep saying Quantum instead of Neutron.
That's okay. We won't throw you out.
We'll bleep it out.
Take it to 10. Yeah. We'll clean it up in post.
Sure.
But one thing that I haven't mentioned is how the image gets onto your machine. I think it's kind of interesting. Right now, it's a somewhat non-scalable way, which is that we actually open up iSCSI on your machine in a tiny little minimal deploy RAM disk. And we just say we find the volume that we want and expose it through iSCSI, and then Nova comes in and just shoves the image down iSCSI. That's actually really fast, but the scalability of that is not great, right? We can only really do 1, 2, 3, maybe 4. Even with a 10 gigabit, we can probably only be able to do 4 or 5. What we'd like to do is actually use something like BitTorrent so when you say boot 10 machines, if it's all the same image, right, they just throw up a torrent and they all get it on. But that's one of those optimizations that we can't do right now because there is still some fiction in this presentation. Yes, I just did say that. I will point it out. This is Robert's soliloquy and golden images. I've mentioned most of this already. We do have a whole bunch of what we call elements. So this image builder is built around kind of like Juju Charms, but only the install part of it, not the relation part of it, where we define, SEP scripts. Like it's really, really simple and straightforward, easy to read. There's a bunch of scripts and directories that are run in the order that they need to install software, set up partitions. You can put grub on there if you need to boot it as a VM, and then. There's also some pretty sophisticated bits for making it really easy to write templates for big files and things like that. So we've written a bunch of them called triple image elements, which is everything that we use to deploy OpenStack. We've also done some integration with Heat. I talked about all these OS star config tools, each with their own job, collecting, refreshing, and applying configurations. Clever naming. Actually, we call them awk, orc, and oak, which sounds like choking on something. But basically, the way that this works is similar to the way that like Puppet would work from a Puppet master. You have an agent that's running, that's asking Heat if anything has changed, and whenever anything has changed in Heat's world, then it reruns orc refresh config, which then applies all the configurations that it's just found. One key difference is that Heat is not giving you a global, like, here's the manifests and here's your roles. Instead, Heat is just saying, here's your little piece of the world, and here's what the template writer has exposed to you. And you can also look at other pieces, but the access controls are actually pretty strong. So this is the sequence that we go if we want to change something. If I want to change so what's a good example? The limits of requests per second that Nova will handle. I go into my Heat template and I change that value, and then I say update the template, and it goes anywhere that value was used and changes the metadata. Now, one of the things I'm actually starting work on this week is at that point, right now, we'll just keep going on and update all of them. I'm going to actually do it rolling with canaries. So there's a feature that I'm going to build into Heat is it'll go in and change one, and then because that one is part of a canary update group, it'll wait for the canary to say one worked, and then it'll update two. It'll wait for the canary to say those two worked, and then 4, and then 8, and then 16, and then we get to a tipping point and do them all. Or after we get to 20, maybe our load shoots up because the new thing sucks, we roll it all back. Right? So that's the canary-based rolling, which is really critical in a large-scale data set. We can't just shove things out and pray, because rolling back might take hours. So you want to try and catch those early.
And you might not be able to roll back.
And you might not even be able to roll back. In fact, I had a theory you're never actually rolling back, even if you say you're rolling back. You're rolling forward to something that looks like the past. So it's a dicey operation. You want to do it as fast as you can. The fail-fast mantra. Canaries is actually a well-known pattern, stealing a lot of this from what Bosch does, which is the Cloud Foundry tool that replaces Cloud Foundry. Basically just let Nagios or whatever your monitoring system poke something saying yay or nay. Does anybody use canaries? It's kind of a new concept coming from now we're splitting roads into thousands of machines. It's a new thing. So Heats is an orchestration system. We are not requiring use of the op tools. You can use Puppet or Chef to do any of that stuff. Actually, Puppet and Chef already know how to read Heats. So you don't even actually do anything special to start using Heat to orchestrate things. Things that Heat is good at are telling parts of your infrastructure where other parts are. So that's actually kind of something that you have to end up manually doing a lot of the Puppet is like this list of variables. My MySQL server is over here, the slaves are over here, and the Keystone server is going to be over here, and anytime any of that changes, you're manually updating and trying to make sure that you run Puppet on the right machine in the right order to make that work. That's the orchestration piece that's missing from Puppet and Chef. And you can do some of it by just doing like parallel SSH or in collective, or you can just be really careful and just update, one role and then update another and have lots of those statements. And that's a valid strategy. But Heat actually makes it declarative. So you're just saying like this one knows about that one, and whenever this one changes, tell it. It's a much easier when you're doing giant deployments. Like that's the kind of system that you need to help. So that's why we're using Heat.
Where does Heat fit into the Chef stack?
It's above that. So Heat has some tools that work Chef-like, like applying configurations and restarting daemons. It started life as a copy of CloudFormation, and it definitely will probably always encompass CloudFormation. But CloudFormation is like very Amazon world specific. So it doesn't, Amazon doesn't have to care about taking a template from Cloud A to Cloud B, because they're just the cloud. So we're trying to build things into Heat now that allow you to take the template from maybe like Rackspace has a certain set of parameters that don't work the same as HP Cloud, and then that won't work the same as your private cloud. So what we want to do is be able to write a template for your application, and then the porting effort to be very simple and not actually change that template, just change the abstractions underneath. So that's where Heat sits on that level. But the reason I say it sits above Chef is so Chef has like a server that knows all the data about all your things, and it will expose things to servers, but it doesn't handle like dependencies of things. So Heat, I can say deploy this application, and there's a dependency graph. So it'll say like, oh, everything depends on the MySQL server, so deploy that first, make sure it's working. Now deploy the other pieces, make sure those are working. And then the key part is deployment can be kind of easy because nobody expects a thing that you just deploy to work, right? Wait until it gets to the end. But the update, so when you make a change to that MySQL server, make sure that you do it in the right order so that you don't actually break everything. So like for instance, deploy a new MySQL server, suck all the data over to it, and then change the pointers on all the machines when it's already known to be good and working. That's the kind of thing orchestration wants to do, and Heat can do most of that. It does all of it poorly right now. I mean, to be very honest, it's a very simple system, but that's actually a lot of what my job is, and a lot of what a lot of developers are working on. Red Hat has had 5 to 7 people on it for over a year. Rackspace has 10 people working on Heat. HP has 1 person, and there's definitely some interest from IBM. IBM's been participating a lot. So there's this storm of amazing collaboration happening.
And he's going to call public or chef and wait for the return value based on that, but it's not going to have much visibility into the nature of the failure underlying.
Yeah,
I think
it
it's what
adamantly
they're-
doesn't want to know what's inside your instance. Like CloudFormation, they got a little, they stretched themselves out into that world because they wanted to be able to give you a template that just works. But we're being much more like blinders on, like I give you data, you do the bill, chef, work, tools, right?
Can he also talk about monitoring and
Yeah, absolutely. In fact, we just wrote an image element that when you deploy it out there and tell it, you deploy with heat, and you tell heat to tell it about all your resources, then it's able to just query heat, pull down the template, and just build the Nagios configuration. So, and it actually will also go to Keystone and ask for all your endpoints. And, so then you have like the real machines and the endpoints. Now, connect the dots. No, it does not have to be Nagios. We did Nagios because the guy that we had doing monitoring has experience with Nagios. I would love to see another system. I like Ichingo. I like the crazy mad scientist in me wants to use assimilation monitoring. It's a big deal. It's amazing. Just go check it out. I'm not going to find it. But it was invented by the same guy who invented Heartbeat. Who's heard of Heartbeat? Yeah, and he's kind of a wingnut. I love assimilation monitoring. Go check it out. So, and this is the part where I go to PowerPoint karaoke. So, apologies. So that side of encompassing the deployment. A big part of what we are focusing on is things that will not sacrifice time for a deployment. Meaning, we ultimately we want you to be able to, like any OpenStack user, to be able to go grab this set of tools. You know, the progression is you have like my laptop will have a VM that's like the seed for the cloud, and they'll plug it into their data center and use that seed to deploy on the 10 bare metal nodes that then deploy the 10,000 that are sitting there blank and ready to go in their data center. Because of that, like we right now we haven't optimized, but we're looking at the architecture as it has to be fast. It has to be scalable, and we can't do anything to sacrifice that. And if you think about OpenStack, it has to be that way. And a lot of things in OpenStack weren't designed that way, right? Like Keystone now. If you read Adam Young's essay recently on like where Keystone needs to go, it's like we're learning, make things scalable. Don't just push it under the rug and say deploy more servers. It's the same thing. This thing has to be fast. So right now we do actually have a proof of concept rack of HP servers that is running it, and when we add a compute node, it takes about 6 minutes. So we say put it in the rack and plug it into the right VLANs and we just need to know the MAC address for the IPMI and the main network interface. 6 minutes later, it's up and serving. That's we need to keep that kind of performance. And that's 6 minutes. 5 minutes and 40 seconds of that is hosting this doesn't even ready control, right? So one of the ways we do this is we have and we actually don't love this. We'd love for it to change, but Nova seems really set on you must only have one config driver, which is that we have the bare metal cloud, and then we have the over cloud, which is like the VM cloud or KVM cloud. So we have to have that separation right now because OpenStack and Nova just won't let us do that. Because we'd love to be able to run pieces of OpenStack on VMs. Like, there's really no reason to run Horizon on bare metal. But right now we kind of have to if we want to use Horizon to manage our bare metal cloud. So we want to be able to change that. And we have some ideas about that. Right now you have this OpenStack bare metal cloud that is the first thing that you deploy with your seed cloud. And then it deploys KVM based. And that's the one with dependencies. You actually end up with two clouds, kind of three, but one goes away. Right, the laptop goes away as soon as it's there. And then, of course, I came up with the idea of so we could, avoid kernel updates. We could also put LXC in there, so we stay tuned for the quad O project where we run OpenStack and OpenStack and OpenStack.
That'd be
Yeah, ooh. Sounds like a show on Cartoon Network. So the undercloud is fully HA. We have deployed it with only one machine right now. We have on our point of contact, our proof of concept is non-HA, but there's nothing preventing us from going for that, because this is where it becomes awesome that we're using OpenStack, because OpenStack, all the benefits of OpenStack we get to use. So it's easy to make OpenStack HA somewhat, so we should be able to do that. Like I said that. So that's how we go through, which is to have the VM and the progression, and that is all I have. So please ask your questions.
So golden images. So there was always a big discussion on like the kind of chef and up world of no golden images, like to build it as code, building golden images, maintaining them, is real pain. So I'm sure you guys had an interesting discussion on that, and I was wondering if you could.
We've had a lot of discussions on it. One of the things that we're doing is kind of evoking the experts here. Netflix uses golden images, and they're trying to deploy at a scale that is arguably smaller than some OpenStack public clouds, but certainly large scale deployment, and they're being very successful. Golden images are just collections of software that came from a definition. So the manager of them, we do have a service for that, it's called Blanks. It does have metadata attached to those. They have names, they have unique identifiers. At some point, image soup is a possibility. We could have 40 or 50 images just to deploy one OpenStack. Thus far, our proof of concept has 2. Control, compute. Now, we anticipate as the demands go up that we'll need to have 3, which is control, network, compute. But that's 3 images, and then each one would have versions, so that there'd be sort of a line of versions of images from there. But
it sounds like there's a series of scripts that are used to build it.
that's the
So
image builder.
This isn't really a golden image anti-pattern to me. This is more like a build the software from source, deploy it as a binary.
Sort of. It is. You
Is
still
it-
the hard work once.
Because like the problem with the golden image is always who changed what, how did it get the way it did. You don't have this problem because it's right.
We do. I mean, we need to know what version of Nova is on that, and what version of EBR, broke.
So you have the metadata, but wouldn't you basically tie that back to like something in version control that says this is the state of how it was built?
So there's been talk of wanting that, being able to like log into a machine and know everything possible. Everything has a version attached to it, Python modules, and we leave the Git trees there, so you know what version you have from Git. I don't see those as huge problems in an image. What you really want to know is what change broke it, right? So you do know that because you know what caused the image build. So it's just, you have Jenkins, right? Jenkins sitting there watching the trees, and when Nova gets a commit, you start your whole process. And I'll go back to the slide because I think it helps answer this. It's complicated, but this workflow is actually really predictable. So when it comes out of that save result right there, right? Save result, you know where that came from. That's a short period. And that is the only time you're creating a new image. So it either works through your testing, right? This is the test phase, and gets kicked into production, or it fails and it goes nowhere. It dies. It goes, nope, that commit breaks everything right off the point.
I like everything I'm seeing with this. How can I buy it?
Awesome question. My overlords would be pleased. Someday, obviously HP is putting quite a bit of money. We have 5 people on our team working on this. We would like to productize this, but it is somewhat skunk worksy right now. It's also entirely open source, and HP is really committed to like growing the OpenStack ecosystem and being a leader in that, and not just being like, oh, we're going to go, and suck all the money out of it early, because we've seen what happens there. It just delays the inevitable, and that player never wins. So HP is there, putting money into this, making OpenStack deployment better to make OpenStack better. Eventually, you can go buy an OpenStack Cloud from HP right now. There's several different versions you can buy. Cloud OS is the one that's got the broadest distribution, and that one's working now, but it has scale problems. So that's based on some internal tools, some other open source tools, and they'll tell you right now, like, that's great for a rack. But yeah, if you have a problem that a rack can solve, then call up the Cloud OS folk. Send me an email and I'll get you connected with them if you want to buy that. That is not this though. That is, we hope someday going to be this, because there's this hope. While we call it O, this is actually OpenStack deployment. So one of the reasons. One of the reasons we even took the step to make this a program officially in OpenStack is to gather support. If you look at what Heat has done, like somehow magically Heat got in front of the need for orchestration inside the car, and so there wasn't a lot of like people out there doing something with that problem. Juju's out there. There's some old projects that aren't really suitable for the cloud, like Control Tier. But because of that, because it got good enough, like IBM came along and was like, oh, let's not worry about anything else. Let's contribute to it. Let's contribute to Heat. HP comes along and says, let's not build something ourselves. Let's contribute to Heat. So there's value in having deployment at that same level of buy-in, where it's like, this is the way that we're gonna focus on helping people deploy. Now, it doesn't mean that Puppet can't come in and play in this deployment space, because there are 3 jobs that Puppet does well. They're more than what they're already doing this. They're already deploying. So I'd love for them to now take their StackForge Puppet manifest that they have right now. Are you using those, by the way, or you have your own stuff? So what I'd like to see for them to do is integrate that into Triplo. So go, look, you can use Triplo native, like the OS star config tools, or hey, you're a Puppet shop, use Triplo Puppet. Triplo. Any other questions?
So one caveat that springs to mind is rolling an existing set of VMs forward as exchange compute-wise.
It's nice, like lost over.
And it would seem that you want to issue an evacuate command to your legacy hypervisor as you want to decommission it. And those things don't always play nicely together, rolling from one version of the hypervisor to another. Not necessarily the hypervisor version, but the compute control services that change over time.
Yeah, so there's really 2 update problems in OpenStack. There's updating OpenStack and updating compute. Because compute has the problem of having state in the VMs, running state. Like there's no way around it. Live migration is a thing, right? But nobody seems to be excited about it. And in fact, because you incur a huge penalty when you're doing it, it may not be worth the benefit of keeping those VMs running, because they can run like crap. It might be better to just shut it down for 10 seconds and have evacuate show up on another machine, right? Which is what you're suggesting. For the non-compute problem, it's actually pretty interesting. We have a proof of concept for that, for updating a building image without rebooting and in a very clean way. So that's one of the scary things with golden images too, is like, how do you update it? You don't have to deploy a new one and reboot it. What we do is we download the image from Glance, open it up, and then because we have carefully, and I say we will carefully put all your data on another volume that's rewrite. and we know that we have the root file system, we will have the root file system, read only. We can just remount it, read write real fast, and do rsync one file system over top of the root file system. So the symlinks will all be in the image. They'll know where the data is supposed to be, whether there's like things that have to be in the user in the data partition. The idea is really fast. Download the image, open it up, rsync over top, and then read mount, read only. So now you've updated the running system, and then you run the orc tool, which stops all the services and starts it back up as a rule. So that's how we do non-compute. For compute, same thing, but in the middle there, there's a reboot and a back boot. Because I think it was up there somewhere, but compute is fragile, so we have to be careful. But the idea is to do a really clean, entropy-free update of the machine. We would eliminate, if you had been a bad admin and gone in and changed something by mounting read-write, right? It's gone. It's gone. We're going to run it, delete. We're going to run it, and everything in the root file system will be gone.
What's the fictional part?
That part.
Which part?
The part I just described is
Oh,
fictional.
okay.
Because we haven't gotten to it yet.
I
So
see.
our proof of concept actually, we expected it to live for 2 weeks. We had some people wanting to use it just to test some things, make sure that we could actually deploy it on. And they liked it so much that they asked to keep it for 3 months, and we were like, okay, we can't update it. So right now we just go in and like log in and do a git pull and rerun all of our install scripts again. Not cool, and not the plan. But the reason that we're sort of hemming and hawing on that is that we want to wait for Ironic to have the data volumes, which I haven't gone into much because they're still kind of in the spec phase. But you want to be able to, with the compute node, to be able to delete it and then recreate it with the volume. So your evacuate actually isn't even moving anything. It's just a redeploy of the same machine to the new kernel, basically. So we aren't spending time doing it the wrong way. Because we could do it right now by having a partition just in the machine, but we can never get that data back if we deleted the node. So it becomes volatile. That part's fiction. Heat doesn't do rolling updates, but I think I said I'm working on that this week. But other than that, though, what I described has been used to deploy OpenStack multiple times, and you can try it out. There's a URL. Go to the StackForge project. Look for O stuff. There's a O incubator, and in there there's instructions on how to get this running on a laptop without, like dev test, ruining your laptop. Don't run dev test on your laptop.
Is this ready for me? Can we start playing with it?
You can start playing now. Production, I would say, is dicey because of the update problem.
Because of the update problem.
Yeah, but if let's say you forget golden images and forget the OS star config tools, right?
Yeah.
This is still useful if you want to use your Puppet and Chef stuff now, but you want to use OpenStack for provisioning and Glance for your images, even though you'll just be using vanilla images. Like it's still useful, and that's part of that one job, one tool thing. Pieces of it are useful now.
Okay.
If you go near current banana release, depending on what you need.
It's useful-ish.
So,
It is very useful.
Is there a time set limit on how long it will take for you guys to fix the update problem? Or will it out?
Yeah, we've got some deadlines. I mean, they're not public, but soon, very soon actually, and that we want to keep our proof of concept from going away of entropy and value, just because we don't have time to maintain it. So we'd like to solve this tomorrow, but until Ironic has the volumes, it doesn't have to have it, but the spec needs to be in there. We need to start developing it so that we can not shoot ourselves in the foot when we do it.
So what version of OpenStack should I be looking at?
That is a huge question. I mean, the easy answer is just do basically packages.
As long as you don't need complex parallel provisioning, or you want to say that based on one of your Neutron networks to attach, each one to the database network and whatever to the storage network, then you go, otherwise you got to wait until you can assign those.
Yeah.
based on the.
I'm a big believer in continuous deployment of Git, whatever is in Git now. You have to understand the high quality of the gate. I mean, it's not perfect. We've broken tons of stuff, but it's treated as a problem for everyone, and everyone wakes up and solves it. So, like, I know Rackspace runs a couple weeks behind Trunk. Parts of HP Cloud are that way, and most of it is on Grizzly anyway. But that's where, when you're in a large scale, where you're developing a lot, it's that way that's supposed to be. Because the problem with deploying Grizzly is if there's a bug that you find that's critical for you, it'll be fixed. There's a stable release. It'll be in a month. But until then, you have to patch. It's like now you have all the pain of continuous deployment without any of the benefits because you're running patch. So I say if you just like get in the mindset now, just continuously deploy, have tests for what you needed to do, then you're getting sort of the best stuff early.
And dissociating yourself from packages is key, as I've actually found out the hard way recently, where the recent Ubuntu Nova common package was insisting on trying to run a Nova managed DB-sync, but my public manifests had the setting up of the databases after the package installs. Right, so it was banging its head trying to do a DB-sync, but the database users haven't created yet, and it's like, well, shit, now I got to refactor the entire public manifest to deal with this package change. So getting away from that, I think, is a good thing.
That's gonna. What you're running into is the problem where software and configuration are done together. Actually,
right.
The original version of this graphic I made had packages in here as doing software and configuration and state, right? Which is funny because that's kind of Chef Puppet's job, but
Sure.
that is the problem, is that before we had Chef and Puppet, Debian and Red Hat had to have a solution for this. Right? Especially Debian did a really good job for the install once and keep a server for 10 years problem set.
Yeah.
Packages are great. For what we're doing now, we have config management separated from software, packages get annoying a lot. And I say that as a Debian developer and a Ubuntu core dev who has a lot of time invested learning how to make packages. For this problem space, packages are getting annoying. Yeah. It's 8:30, so if there's no more questions, then we should probably wrap up. But again, thank you very much. Thank you.
The OpenStack Foundation.
You guys use an OpenStack?
I just want to join all of you and wish you OpenStack a happy third birthday.
We developed
Really, it's all about the
right,
community.
that's right.
It's all
I
about
remember
the
you guys
contributions that have been coming in from the very beginning. We've seen this community founded on some very important core principles. And with those guiding principles, the community has grown at an incredible rate. We had 20 some odd developers contributing 3 years ago, and now we have over 1,000. I mean, it's unbelievable that that's happened in only 3 years. And, the user groups are very vital to the future of OpenStack. We've seen those established in over 40 different countries. And that's just incredible to me from the very early beginnings. We had 75 people at our first design summit. Now we're seeing thousands of people attending summits. And our next one, of course, is at Hong Kong, November 5th and the 8th. So I hope all of you can join us there. And less than a year ago, a very important step, I believe, in the future of OpenStack is creating the foundation, the OpenStack Foundation. And we now have over 10,000 members from over 120 countries. And that diversity and that membership base, that is what it's all about. And that's what's going to carry us for the next 3 years. And, not only have we seen these incredible numbers in terms of participation and excitement, people getting involved in OpenStack, we're starting to see some very, very big users. And they're, of course, what we all fight for. We fight for the users. And we heard from some of those at the last summit, like Bloomberg and Comcast and Best Buy. And we're starting to hear more from CERN about what they're doing. And NTT, the list goes on and on. And what's exciting for me is not just the type of innovation that's enabled by moving more quickly. These companies, such as PayPal, has talked about how much more quickly they can release new features because of the agility of OpenStack. Not just that opportunity, but the opportunity for the individuals. Many of you who are getting involved in OpenStack, starting businesses, getting funding, helping users. It's just incredible to me that people are getting trained and learning these new skills, and it's opening up new doors. Look at the number of job openings related to OpenStack. It's just incredible, and for me, the opportunities for the individuals are really, really special, and I think that's the biggest impact we've really made, honestly, is really trying to create this economic opportunity for everybody who wants to get involved in OpenStack, and also ensuring that the future of cloud computing is free and open source based. And that's really because of those core fundamental beliefs and values that haven't changed a bit despite how fast we've grown. In fact, they are the reason we've grown so quickly, I believe. So, we've talked many times about the four opens: open design, open development, open community, and of course open source, the one most people think about. And those haven't changed a bit. I don't think they will. And I think if you look forward to the next 3 years, where we're going to be in 3 years with all of your help and all the people that are joining every day, I personally believe that the combined power of the OpenStack community, of every OpenStack cloud on the globe, will be far bigger than any one service provider 3 years from now, even bigger than Amazon. I really believe that, and I think it's because these core values really carry through. Open source is the way cloud computing is meant to be. It's too vital for our future economy of just about every business on the planet for it not to be open. And so I think it's going to win, and I think it's because of all of you. So again, I just want to thank you so much for being part of OpenStack and making OpenStack what it is today, and taking us to the next 3 years, to the next phase of OpenStack world domination. So happy birthday, OpenStack, and thank you to all of you.
Sergio Mubarak, OpenStack. Sergio, Sergio Mubarak, OpenStack.
Happy birthday from Triple O.
Happy birthday, OpenStack.
Happy birthday, OpenStack.
Never stop.
Okay.
Never.
Who's the leader guy?
Never turn it off.
There you are. Yeah. Now it's a party. Yeah. There you are.
Okay, let's see if I can. We all
Not
speak
chipping the
together.
stick any
Okay. 1, 2, 3.